Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 52 off the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got this function here, y equals 3.75 plus 1.5 parentheses x minus 1. It can be used to determine the cost in dollars for a taxi ride of x miles. So we're looking for the rate of change for these two things, cost in dollars with respect to. So that is just kind of a different way of letting us make a ratio. So we're going to think per. Cost in dollars per, and then number of miles. All right, so let's write that down. So we're going to say cost dollars, and then number of miles. And so we know that's going to be a ratio because we've got two clues. First, we've got this with respect to, but also it's the rate of change. Right, and that rate kind of gives us a little bit of a clue that we're also going to be looking at a ratio or a rate. All right, so what is my cost? Well, the function y equals all of that whole thing can be used to determine the cost. Okay, so here's my cost. So what is the cost? Well, look at the way this is written. It's y. So y equals all of that. That's actually the cost, okay? So that's the cost, and then the number of miles, there you go, that's my x miles right there. Okay, so I've got y over x because my cost is y. X represents the number of miles, which shows up in my actual function right there. But I'm looking for the rate of change. So I'm looking for the change in y over the change in x. That's the Greek letter delta, looks like a triangle, just means the change. So we've seen that before. What happens when we get the change in y over the change in x? Sometimes we'll call it the rise over run. Yep, if you are thinking slope, you are correct. So really, this rate of change is just asking for the slope. And take a look at my equation up there. This function up here is pretty close to my slope-intercept form, right? So if I can get it to look like this, y equals mx plus b. That's what I'm looking for, is my m, right? I'm looking for that coefficient that's right in front of the x. I don't really need that b, but if I did, that's the y-intercept. But really, I'm just looking for that slope. All right, so first off, let's just go ahead and flip these two terms so they're kind of in the correct order, right? So I've got y equals, now I'm going to put the 1.5 x minus 1 plus 3.75. All right, so here's my y-intercept right there, or at least it looks like my y-intercept, but this, that's kind of interesting. But you know what? We can go ahead and distribute that out. Let's do this. 1.5x, right? So we're just going to distribute that out, minus 1.5. Okay, so that's what that is, distributed out. Then I'm going to add my 375. So really that's like 3.75 minus 1.5. So here's my final equation. Y equals 1.5x. And that's going to be 3.75 minus 1.5. So that is going to be 2 25/100ths positive. So there we go. That y-intercept would be that 2.25 if I need it. And then here we go. Right there, you see that 1.5? That is my slope. Now remember, that is going to be the cost in dollars, right? Is really what's in front of that x. So since we've got the 1.5, we need to put it back in dollars and cents, which is not that difficult. The answer here is going to be F.